The problem statement with the increasing volume of temperature data collect over multiple years, the traditional single machine data processing method become inefficient and wasting time. So there is need for a scalable and distributed approach to process and analyze large data set efficiently. Next, the objective. The objective that I need to achieve is to implement the first to implement Hadoop MapReduce. The second is to calculate the average of weather temperature for each year from year 2015 until 2025. And last is to understand the MapReduce processing model like the MapReduce workflow. Next, program and dataset information. So the MapReduce program for this project is average weather temperature per year from year 2015 until 2025. So the purpose is to calculate the average of weather temperature for each year by using a MapReduce framework. So the tools that I use is Java, Hadoop 3.3.1, the Eclipse is for writing the Java coding, and the terminal is to execute the output. So the dataset, the file name is weather temperature text file. So inside the text file, the format is the left side is the year and the right side is weather temperature. So look at the below. So they have 51 data record. So the left side like 2015, 2016, 2020 like that is the year, and the right side like 18, 21, 24 is the weather temperature. Next is the MapReduce workflow. So we have input session, mapper session, suffer and sort session, reducer session, and output session. Because they have many data record, so it will take place. So I use two page for MapReduce workflow. So the first input session. So we need to input the data from the weather temperature text file into the MapReduce. So the below one is the data from the text file. So next is a mapper session. It will read each line of data record and then extract the data record become year and temperature as the key value pair. So the key is year and the value is temperature. So the output will become bracket. The inside bracket have year, comma, temperature. Like the example is 2015, comma 15, 2015, comma 18. So after the mapper session, next is suffer and sort session. So suffer and sort session, it will group the temperature by year. So like the example 2015, the temperature have 15, 18, 21, 24, and 27. So it will group together will become 2015, comma 15, 18, 21, 24, and 27. So the same like 2016 until 2025. This is the second page of MapReduce workflow. So after the suffer and sort session, next we go to reducer section. So the reducer will calculate the average of temperature for each year. So the example, the 2015 they have 5 temperature, so they need to sum 5 temperature divide by 5 because they have 5 temperature. So the answer will become 2015, comma the average temperature 21. So same like the 2016, they have 4 temperature. 4 temperature, so they will sum 4 temperature divided by 4. So the answer will become 2016, 20.5. So the same like 2017 until 2025. So after the calculate average temperature, so the output will become 2015, 21, 2016, 20.5, 2017 until 2025, 32. So the output will store in the Hadoop distribute file system, the HDFS, for analysis. Next is the driver session. So this has 3 session, mapper session, reducer session, and driver session. The mapper and reducer session I already explained in MapReduce workflow. So I will explain the driver session. So the driver session will configure Hadoop job, and then set mapper and reducer, and then define input and output path, and submit job to Hadoop. So this is the output. So in the terminal I use the coding that have teach in the tutorial. So this is the output of average temperature. So they have 2015 until 2025, and then the right side is the average temperature for each year, like 2015 have 21, 2016 have 20.5, 2017 have uh, 22.16668, and 2018 have 23.25, 2019 until 2025 have 32. In conclusion, the Hadoop MapReduce program is successfully implemented to calculate the average weather temperature per year from 2015 to 2025. The objective of understanding the MapReduce processing model is achieved, and the Hadoop MapReduce is suitable for handling large-scale data efficiently and accurately.